All right, all right, all right. It's Professor McStud, and we're going to be wrapping up our factoring trinomials, kind of mashing them all together, a few different looks at this. So if you look at this first one, we have a 1 as a coefficient of our x squared, or our squared term. And then we are, so with that, you can just find factors of 30 that subtract to give you 13, which would be 15 times 2. So here is pretty, remember, straightforward. We have two factors, s and s, and then we have 15 and 2. Larger of the two factors gets a minus, the other one gets a plus. There's your two factors. So kind of sort of just a quick refresher from that. Just make sure that you have s there, because that's where that is here. All right, so then on this one, remember, we have a 2 in front of our square term, so therefore we're going to do the box method. That's when we do the boxes, when that square term is not 1. Or the coefficient, I guess I should say. All right, so here we have factors of 28 that subtract to get me to 3, which would be 7 times 4. So I have 2r squared and minus 14. And then I have 7r and 4r. And the smaller one needs to be minus, larger one needs to be plus, because they get this sign right there. Okay, so now we're going to find greatest common factors. And this one's going to be 2r. This one is going to be 7. And then greatest common factor here is r minus 2. This is a plus positive. All right, so then factors here are going to be 2r plus 7 times r minus 2. That's the factors there. Number 3 here, we're going to find factors of 70. So that's a pretty large number, lots of factors that are going to add to get me to 19. So if you're not sure, then you can start off with just doing like 1 times 35. 1 times 70. Got ahead of myself. 2 times 35. 4 times 15. 5 times 14, 7 times 10. Okay, so those are going to be all my factors. So here I have 2 of them that are going to give me, oh wait. All right, so got a little bit ahead of myself. This is not 14 times 5. Ooh. All right, so it is 5 times 14. That would get me to 19. So therefore, since my first number in front of my square term is not 1, then I am going to do the box method. So 10y squared and 7, and I have 5y and 14y. Both of those are negative. So that's where you need to be really careful with this, because this is going to be a little bit different just because of this, and you kind of sort of need to know some rules on that. So we'll talk about it. So greatest common factor, the left column is going to be 2y, right column is going to be 1, top column 5y, bottom column 7. Now, if I followed my rule of like greatest common factor or factoring with like if they both have negatives, and it's going to be a minus. Well, technically, this instance, when this sign is a plus sign and this is a minus sign, then they're both going to be negative. If it's a plus sign and a plus sign here, they're both positive. But the only instance is a little bit funky is here, and so that's your rule. That will always be the case no matter what. So we have 2y minus 1 times 5y minus 7. And it all ends up because 2 negatives multiply to give you a positive. So that's kind of sort of where that comes from. All right, and then this example here, you'll notice I have an x and a y. I have an x and I have a y. So on this one, no need to freak out. We're still going to use a box method. We're just going to have a little extra variable with us, kind of hanging out with us this time. So we're going to find factors of 12 that subtract to give me 4, which I think is going to be 6 and 2. So I have 4y squared here minus 3x squared And then I'm going to have a plus 6xy because that's what's the term here. And then a minus 2xy because that will give us the 4. So greatest common factor here is going to be 2y. Greatest common factor here is going to be 3x. So notice I have an x and a y in both my terms here. And then a greatest common factor here is going to be 2y. Greatest common factor here is going to be x, minus x. So it looks like a plus because of the box on the other one. So I have 2y plus 3x and then 2y minus x, or 1. If you want to do 1x, that would be okay. But technically it's just x. So that's kind of what it looks like with the two variables. So we should have a little extra variable hanging out, and that's perfectly fine. Here we have number 5. Again, two variables. My coefficient in front of my square term is not 1, so I'm going to use the box method. So I have 5k squared minus 2n squared. I'm finding factors of 10 that are going to subtract to give me 3, so I'm going to think that's going to be 5 times 2. So I have 5 minus 5kn and plus 2kn. Greatest common factor here, k. Greatest common factor here, minus n. Greatest common factor at the top is going to be 5k. Greatest common factor at the bottom is going to be 2n. Yeah, 2n. So final here is going to be k minus n times 5k plus 2n. All right, last but not least, here we don't have to use the box if you don't want to. I'm finding factors of 1, because that's like what's in front of here. That's going to give me to 2, so that's just going to be 1 times 1. And that's only factors of 1 anyway. So here's what this one's going to look like. So I have u and u, and then v and v. Both of them are going to be pluses. So this really, technically, you could write this as u plus v squared. So on this one, either one of those is okay. So don't think that, I would accept either one. Technically, this is more correct, but you could write this one as well. So this is what I have for you, factoring trinomials, kind of putting all that together. We had a little extra variable hang out with us today, and that was okay, and we got it all figured out. So either one, you can use a box method, or you can use just traditional factoring method. And so that's what I have for you today, finally kind of finalizing factoring trinomials.